As I stated in the last video, we can work with uncertainty as long as we account for what we call the known digits and one uncertain digit. Let's look at an example. It says here in the statement that I wrote that the way we choose to write a number should not influence how many digits are original digits of the measurement. If you look here, this number, 0.00922 grams, is exactly the same as 9.22 times 10 to the negative third. Except, of course, the only difference is the representation. This was represented in a scientific notation fashion. This one used the decimal. So this should not influence, again, how many digits are what we call original digits. So significant figures are a set of rules that I'm going to go over really quick, but you have to actually know them. And they will be used throughout the whole semester and in all of your chemistry and perhaps all of your science classes. So let's dig in. What are the rules for counting sig figs? You might have remembered these if you've taken a science class before, but if not, we're going to go over them now. Let's begin. All non-zero digits are significant. That means, 1 through 9 significant. So if I have a number such as 119, that tells me that I have 3 significant figures. If I have a number such as 2.223, then that means I have 4 significant figures. All of these are non-zero digits. 2 captive zeros, or zeros that fall between two numbers, are significant. So if I have 109, then that means I have 3 significant figures. So this 0 is significant. So in this case, I have 3. If I have 1.006, then again, those zeros are captive zeros. They fall between non-zero digits. So they are significant. So in this case, I have 4 significant figures. Leading zeros, zeros that fall or are to the left of the first non-zero number, are not significant. They only serve to locate the decimal point. I mean, these zeros. Anything that comes on the left, right? Or they lead the number, those are not significant. So if I have this, then all of these zeros are not significant because they are leading zeros. So I only have 1 significant figure, and that is the 1. Why? Because I can write this number in scientific notation. If you refresh your memory on scientific notation, this number would be written as 1 times 10 to the negative 4. So again, only this 0 appears. So if I have another value, if I have 0.16, again, this 0 is not significant. So you only have 2 significant figures. Zeros that fall after a decimal point and at the end of a number are significant. So those are the numbers that come at the end. But there has to be a decimal point. So if I have a number such as 2.10, this is what we mean by zeros that fall after a decimal point. Here's your decimal point. and this number and this zero comes at the end. So it is significant. Why? Because the 2 and the 1 are known and the 0 is the uncertain digit, but we count it as part of sig figs. So in this case, you have 3 sig figs. If I have a number such as 0.00100, well, remember we just talked about these in 3. These are leading zeros, they do not count. But let's see if the criterion applies, the 4 applies to these zeros. So let's judge. We have a decimal point, here it is, and they come at the end of a number, so they must be significant. So in this case, we have also 3 sig figs, or significant figures. Now, trailing zeros, where you don't see a decimal point, and those are pretty much large numbers, those are not significant. So if I have 1,000, okay, be aware this is not a decimal point, this is a comma. So maybe I should erase it so you won't be confused. But again, a comma is not the same as a decimal point. Well, those zeros, if you notice here, there's no decimal point. If you see no decimal point, then those zeros are not significant because they could have come from rounding a number that was 999, for example. So in this case, you only have one significant figure. If I have 1,000,000, or 3,000,000, still those zeros are not significant. So you only have, again, one significant figure, and that's only the 1. Now, I know these might come to be confusing, but with practice, you will get them. The moment you put a decimal point, then again, this rule does not apply. Okay, by definition, it says no decimal point. So for example, if I put the 1,000, and then I put a decimal afterward, and you've seen that, you might see that, you will see it actually in chemistry, then you actually now, you are sure about these zeros, the zero, the second, the first zero, the second zero, maybe the last one is uncertain, but we remember we count it. So in this case, you actually have all of them count as significant figures. So you have 4. So be aware. And I'll summarize all of these for you in a second. But the last thing is in a scientific notation, you only count the significant figures and the coefficient. So if I have something like 6.02 times 10 to the 23rd, I have no business by looking at this power. And if you actually do transform this or translate it into the standard notation, if you write all of those zeros, they will be trailing zeros, so they won't count. So, but as a rule of thumb is, you only look at the coefficient, which is this number, and you count the number of sig figs. So in this case, I have 3, because this zero again is captive. So how do I remember all of these? Well, if I were you, what I would do, again, everyone has their own way of looking at it, is I would remember when the zeros are not significant. And that would be in 3, and it would be in 5. And then everywhere else, they are significant. So in 4 and 3, just remember when the zeros are not significant. In leading zeros, look for the zeros that come at the beginning of a number. And then in 5, when they are trailing. And it's going to work all the time if you remember. Trailing and leading, but remember, trailing is without a decimal point. This topic requires practice. You have enough practice. Please do enough of these, and you will for sure get them.